Hi everyone. Today we're going to look at what is called a geometric distribution. It is in our group of discrete probability distributions. And this time we're not looking at success and failure in a set number of trials. We're looking at when does our first success occur. So it's about the probability of when our first success occurs. So you can think of it as I'm going to keep doing something until I have a success. So I'm going to keep practicing throwing free throws until I get 5 in a row. Or I'm going to keep buying a certain cereal until I get the prize that I want. So it's about what is the probability of getting that success? When does that first success happen? So we do have some criteria that has to be followed for us to be able to use a geometric distribution. Okay, the first one is that the trials are repeated until a success occurs. Okay, so we're going to keep doing it until we have a success. That the trials are independent. Which is a theme that we're seeing through our discrete random variables. And that the probability of success is the same for each trial. Which again is the theme that we're seeing. Okay. Now we have one more, and that is that there is no probability of 0 trials. Okay, so meaning that you can't have a probability on the 0 trial. You're not doing, like, this first success can occur at 0 trials. Okay? All right, so let's take a look at some of the ways we can get our solutions. So you can use a formula. Okay, so that formula, probability of something, of our success, is success times failure to the trial minus 1. You can use your calculator. Okay, so we're going to go to second vars. Remember, that's distribution. That's going to give you where you distribution menu. And we're going to go down to a Geomet PDF. And we're going to put in P comma X. So success, probability of success and the trial number. And then there is an online calculator that we're going to look at that I have linked in our folders. Okay, all right, so let's try the first one here. A study found that smartphones made by a certain manufacturer had a failure rate of 43%. 4 smartphones are made by this manufacturer are selected at random. Find the probability that the 4th smartphone is the first one to have a failure. So our X is going to equal 4 because that's when we want to have our first success. Our probability is 40.43. Now don't get confused that 43% is the failure because that's what we're interested in. So that's going to be our success. Our failure is 0.57. So if I'm going to use the formula, it's going to be 0.43 times 0.57 to the 4 minus 1. And I'm just going to put that in my calculator and I'm going to get 0.0796. Okay, if I'm going to use my calculator, All right, I'm going to go to second var's distribution. It comes up with our menu. We get, I'll go all the way down to Geomet PDF. We're going to put in 4, 0.43, and we're going to end up with the same answer of 0.0796. Okay, now our online calculator. Okay, so here is our online calculator. All right, it's not going to come up very clearly here, so this is going to be 4, and I know that doesn't look like 4. And just kind of trust me, 0.43. I'm going to scroll down to calculate, and we get 0.07963. Now, it does give you a couple of other things, just like our other one did. Less than or equal to 4, more than 4, which is great. And it also gives you the mean and variance of that distribution. So there's a lot of information here, which is great because once you get into a couple other problems, we are going to need that first success more than the first success and the mean and variance. Okay, and it also gives you a table, which is great. Okay, so we'll be back to that. All right, so let's try this one. Pick whichever method you want, formula, calculator, or online. All right, so we have an experience known that the probability that you'll make your first sale on any given call is 0.23. Find the probability your first sale on any given day will occur on your 4th or 5th call. So we're actually interested in equaling 4 or probability of equaling 5. Now, if you remember when we did probability, or means add. So we're going to need to take these two probabilities and add them together. Okay, so our P here is 0.23. And again, our Q then for would be 0.77. And again, your choice on your method. I'm going to use our online calculator. Okay. All right, so our first success is going to be on 4. And our P is 0.23. And again, you're not going to see that really well, but it does give me my probability of 0.105. And if I do it again for 5, I'm going to get 0.08. So the probability of getting a 4th or 5th call is 0.185. Okay? All right. So find the probability that is, again, your first sales call will occur before your 4th sales call. So we're actually looking at the probability of x equaling 1 plus 2 plus 3. Okay, so again, I'm going to use our online calculator, just I found that to be a little bit helpful because it does give me the probability that 4 or less trials are required for first success. So this is going to be less than or equal to 4. So if I just subtract out 4, it will give it to me as well. Or I can do 1, 2, and 3. So if I just change this to 1, okay, calculate 0.23. Okay. And then I'm going to add 2, which I did earlier, so that's 0.1771. And I'm going to add in 3, which is 0.136. I'm going to round that to 4. So when I add those together, 0.543. Let's go with 5. We'll round it to 4 decimal places. All right, so any questions there, please let me know. All right, so let's talk about mean, variance, and standard deviation. These are pretty easy. Again, there's a formula. We don't really need to do that big long chart like we did before. So remember that mean is the same as the expected value. In this case, we're going to say, when can we expect our first success? So that's going to be mu again. So it's 1 over P. Okay, variance. Okay, omega squared is Q over P squared. And remember that standard deviation is omega, which is the square root of Q over P squared. Okay? All right, so let's take a look at the problem. A sharpshooter usually hits his target 70% of the time. Find the probability that her first hit is on the second shot, and then find the mean standard deviation of this geometric distribution. All right, so we want to know, find the probability that her on the second shot, and P is 0.7, Q is 0.3. Again, I'm going to use my online calculator. So P is okay, so this is 2, because I'm looking at the second trial. And then my P is 0.7. Calculate. All right, so my answer to the question is 0.21, but notice down here it says mean is 1.43 and variance, I'm just going to square that to get to standard deviation. Okay, so 0.21, 1.3. Okay, so our answer to this question is 0.21. Mu is 1.43. Variance is 0.61. So that means our standard deviation is the square root of that, so 0.78. All right, and again, you can use the formulas to help you get to where you need to go. Now, there is a formula, because if you think about it, we want to keep going until we have our first success, so there's no end. So how do I do greater than? Because less than, I can just add up the individual probabilities. But greater than, I'm going to keep going until I have a success, so that's kind of hard. So we have a formula for this. We're going to n is our trial number. And it's actually 1 minus P to the n, which is Q to the n. So we're going to use failure to help us out. All right, so let's take a look at this particular problem. We have the State Department is trying to identify an individual who speaks Farsi to fill in a foreign embassy position. They have determined that 4% of all applicants in the pool are fluent in Farsi. If applicants are contacted at random, how many individuals can they expect to interview in order to find one that's fluent in Farsi? So remember, expect is mean. So that's 1 point over 0.04. So that's going to be 25 applicants. What is the probability they have to interview more than 25 until they find one that speaks Farsi? Okay, so that's going to be Q to our 25th trial. So Q would be 0.96 to the 25th. Now again, I could very easily use my online calculator, but since this formula is not too bad, I'm going to do the computation using my calculator. All right, so if you have any questions, please let me know. Otherwise, have a great day, guys, and please stay safe by staying in.